now the functions unit. So the first section is just going to be basic stuff. We'll start with the definition of a function.
Are you YouTubing this or no? Later. No. Record it first.
A function from A to B is a rule that assigns to every element in A exactly one element in B. So let's say this set is A, and let's say this set is B, and in A I have some objects, numbers, or variables, it doesn't matter what, but let's say they're A, B, and C, and in B I have the letters D and E. And now for A, I'm assigning the value that when you plug it into the function, the output is D. When you plug B into the function, the output is also D. And then when you plug C into the function, the output is E. And then this is what we call F. So the function F takes A to D, B to D, and C to E. Okay? Look at the definition and see if it makes sense here. So our rule is right here. It's visualized right here. If every element in A is assigned exactly one element in B, we say that this is a function. Okay? So what do you guys think? Is this a representation of a function or not?
No.
Is it worded wrong?
Yeah.
Every element in A is exactly one.
No, it's not worded wrong. Is every element in A assigned exactly one element in B?
Oh, yes.
Yeah, it is. A goes to D, B goes to D, C goes to E. So this is a function. What would need to happen, let's do another scenario, for this to not be a function? Eric?
I think we learned something kind of like this in algebra. Is there ever a time where, like, does it matter? Like, what if you had, like, two function things, or, like, two things in A and then three in B? Like, would that be a function?
So let's say this is what we're working with. Give me an example. So what do you mean two things in A?
Like, look at the first example.
Yep.
Said, like, there was A, B in A, and then C, D, E in B. Would that be a function or no?
It depends. It depends. You're on the right track, though. Look at the definition in the lingo and the wording here. Every element in A has exactly one element in B assigned to it. So right now, is this a function?
Yes.
What if I did
Yeah.
this?
No.
Now it's not a function. Because A is assigned two elements in B. It has to be exactly one.
The work if they're crisscrossed, like A and D and B and C.
Yes.
So basically,
So CJ says, well, what if it's like this? Does A go to exactly one element in B?
Yeah.
Does B go to exactly one thing in the other one? Absolutely. So this is an example of a function. You guys see kind of how these work? Okay. Usually, this A set represents X, okay, or the dependent variable. And then our outputs are over here in set B. So usually that's the Y or the independent variable. Okay. Any questions on visualizing functions? Yes, not a function, why, and all that stuff. Okay. Let's go on to finding domain and range. So, let's start with a familiar example. And let's just start with the domain. How do we find the domain?
Can equal to a negative number.
What cannot equal a negative number? You're right.
X.
X could be negative.
Cannot equal to any number less than negative. Y.
So in here, the number inside of the root, which in this case is 3x plus 11, cannot be negative, right? So we say that that's greater or equal to 0, right? And now if you actually solve for x, you get x has to be negative 11 thirds. Greater than or equal to negative 11 thirds. Okay, we've done these before, right? Just wanted to review one real quick. You already have some ideas, right? Like fractions, what do you look for the domain?
Not to be 0.
What not to be 0?
The
The denominator. That helps you find it, right? You should have some ideas like lines are always all real numbers, right? Quadratic is always all real numbers. Okay. Let's put something together from last chapter. How do I find the domain of something like this?
Right. It's a bomb.
No,
It's just an alarm or something.
no, it's some unknown number.
Oh,
I should answer it.
I did? Really?
I told you it was a bomb.
all right, let's move on.
That's always what the unknown numbers
They know who we are
You
now.
answered it?
Hold on. How do we find the domain for this?
Vector.
Factor? What are you talking about? What's the very first thing I do to find the domain?
Can't be 0.
It can be 0.
It can't be less.
Can't be negative.
The outcome can't be.
You guys, it's the same question as before.
Yeah, well,
Yeah, but you
outcome
factored
can't be.
after.
I know you did. Oh, so you guys are ahead of me. Okay, all right, settle down now. So x squared, I'm slow, I know, I'm sorry. X squared minus 5x plus 6 has to be what?
Greater than or equal to
Greater than or equal. So we start out like this, and I think you guys hopefully knew that. And then that's why you're yelling at me to factor. Okay, fine, I'll factor.
Wait.
Negative
I feel like
6.
it's-
X minus what?
Negative 6. Kidding. 2 and 3. Negative 2 and 3.
Okay.
Right.
See?
What?
So now how do I solve this strange looking inequality?
Key numbers.
Yes. You mean we have to know material from last unit? Yeah.
That is so ridiculous.
So what are the key numbers?
2 and 3.
2 and 3.
Wow.
Mr. G, what was the
1, 2.5, and 4.
You want to check 1, 2.5, and 4? Alrighty, so let's plug in 1 into the first and second factors. I get a negative times a negative, which is positive. That is
Wait.
good in this case, right? 2 is closed. 2.5, positive, and then negative. Is that good?
No.
Because we want to be greater than 0, right? 4, if I plug that in, both positive, that's a yes. That'll be greater than 0. So my domain here is actually represented by this number line. So let's just write the interval notation for it. That would be,
Negative infinity.
yes,
Comma.
2.
Bracket. Union.
Oop, that's closed 2.
3.
3, infinity. Okay? Elliot, you're all right there? A little worried about you. Okay.
You always
Do we
gotta be worried
take-
about Elliot.
Yeah.
Wait,
Okay.
You do. No test.
We're going to do one last example. But for these kinds of questions, we're going to talk about how you can find the domain and the range now. Okay? So let's say we have y equals 2x plus 1 over 3x minus 5. Raise your hand if you think you can quickly tell me, or you know how to find the domain for this. If you're pretty confident, like, yeah, I think I know what the domain's going to be. Really? Only like half of you?
I should not be able to do one or two.
Okay. Let's pick a random person. Kevin Conrad.
X equals negative half, and then x equals 5/3.
You're close.
Small is light.
What?
You're close.
How did you do that?
So to equal to 0.
What equal to 0?
Equations.
All
Except.
Just a
Denominator.
Yeah,
All answers
it has to be greater than, or it has to be greater than 0.
It could be greater or less than. Okay? Remember, the easiest way to think about domain, most of the time, it's easier to find numbers that don't work.
Yes.
Right? And if you find the numbers that don't work, then everything else has to work. Okay? And right now, we know that what doesn't work? 3x cannot equal 5, so x cannot equal 5/3. So this is one way to write the domain. So here's our domain. And again, the reason is you cannot divide by 0. You can have anything on top, negatives, positives, 0. You can have anything on the bottom except for 0, so x can be anything but 5/3. Okay? Now, the range. Okay? It's not all real numbers. Okay, and I'll show you why in a minute. Right now, this function, let's write it down like this. When y is alone, we get an idea about what we can do with x, or not do. Because right now, if you look at just y, the way it's written here, you know, it might think, well, y can be anything, right? Well, not necessarily, because y depends on what this is, right? So it's hard to see if I'm actually going to get to every single number on the number line. So here's the key that's going to help you guys. When y is alone, we have a good idea about what we can and can't do with x, right? So when x is alone, oh, thank you. When x is alone, we get a good idea about what we can or can't do with y. So the key here is, when y is alone, I can find the domain. If I can somehow take this equation and solve for x, so that it's x equals something, and it's got y's in the formula now. Now I'll see how all the y's are related to one another, and maybe there's going to be a way to find the range. Okay? So let's take a look at this fraction up here. If I want to get x alone, what could I do first? Multiply by this denominator here? Okay. So then I get y times 3x minus 5 is going to equal 2x plus 1. And if we want to get x alone, we should probably get all the x's, what? On one side. If I distribute, I get 3xy minus 5y. And then you guys said, let's get all the x's on one side. So let's do 3xy. And if I move the 2x over, it'll become minus 2x. And then on the other side, I get positive 5y plus 1. Is everybody okay with what we've done so far?
Why did you set the first step like that? Like what?
Because we're trying to get x alone, right?
Oh,
Right now I can't get x alone because I have a fraction. So the first thing here is to maybe multiply by the denominator so that the denominator goes away, and then we have a nice equation without a fraction in it. So that's all we're doing.
So what is it that you found the first thing with d equals?
That's the domain.
Okay.
Right now we're trying to find the range. So the idea is maybe if I get x by itself, I'll see how all the y's are interacting with one another. And I can maybe there's going to be some restriction that I can look at there. Okay? We're actually almost there. How do I solve for x?
Divide by what?
Divide by y
Or no.
gets me 3x minus 2x over y equals 5 plus 1 over y. I'm not sure that's going to help anything. Factor what?
X.
Factor an x out? Good. What's left when I do that? 3y minus 2. I know you're smart. You just talk too much. You can't argue with that. He knows it's true. What's the last step I do? We divide because we just want x alone. So 5y plus 1 over 3y minus 2. And you see, now we have this relationship that tells me how all the x's are related to the y's. Y's. Okay.
Put it back into a fraction.
Right, because now, what do I know here? If the denominator cannot equal 0, again, now I know that 3y minus 2 cannot equal 0. So what's the one thing I know that y will never equal? Y will never equal 2/3. So there's our range. Erica?
So with like normal numbers like these, it's basically like you switch the numbers around. Cause like you ended up with like y equals 2x plus 1 over 3x minus 5, and then now x equals 5y plus 1 over 3y minus 2. Like the numbers aren't supposed to change. Like the coefficients are still like 2, 3, and 5.
Yes, these coefficients are going to be the same, but the pluses and minuses may change depending on... But yeah, you're right. We're not going to get a 7 magically if it's not in there already, because all we're doing is just moving the equation around to have x alone instead of y. Okay? Any questions on that?
Oh, so with the integral notation,
Ooh, that's a good question.
the negative infinity, it's 2/3, all parentheses,
Yep.
union, and then start again from the
Absolutely, because if everything works except for 2/3, think of the number line if you're not seeing how that works. There's an open circle on 2/3, and then everything else works, right? So that's 2 separate intervals.
I'm just curious because there's also the matter that y does in fact equal negative 1/5. So I don't know if should we even bother testing that or not.
No, it'll be fine.
Okay.
Yeah. Because that's in the numerator. The only thing we're worried about is not having a 0 in the denominator for these fraction problems.
So we do write interval notation?
You should be comfortable doing anything. If I say just find the range, you could just say, well, everything except 2/3 is good. If I say write the range or domain in interval notation, then you should be able to convert to the other format. Okay?
But
All right.
What about when we found that x doesn't equal 0? Is that the domain?
Yes. Up here, x can equal 5/3. So if I wrote this in interval notation, guys, what would this be?
Negative. Is it the same thing?
It's the same thing, just 5/3 instead of the 2/3. Yeah. Okay? Either format. Got to be comfortable with it. All right? Yep.
So with finding the domain and range, because like the bottom can't equal 0, it'll never be like the never set it equal to, right? It's always going to be just
Naughty.
like it can't be 0. So it won't be like we have to use brackets because it can't equal a certain number. It has to be like.
It has to be parentheses. Yeah, exactly. Okay. Last thing on the board there. So we talked about definition of functions. We talked about how to know from those pictures if the relation is a function or not. We know how to find some domain and ranges now for some different functions. The last thing is to use function notation. This should be easy. You guys have done this before. So let's just review quickly what function notation is. And I don't know why I wrote that twice. Sorry, long night last night.
Party hard.
No, we had a math contest.
Oh.
Party hard? What are you thinking? And then I got home and my dog got skunked, so I was up dealing with that.
Why are there so many skunks around?
I don't know, but we got...
Everywhere. There was one from the school. I got so scared.
So should I assume when you say I had a late night last night that you guys are partying hard?
Yes.
Oh my gosh.
Yeah, we were turning her up at the football game.
Hey, I love how all this is going online.
Yeah.
Hey, you balled hard though. Yeah, Mr. G, what was the stat line this morning? Tell YouTube.
They don't need to know about my shortcomings in basketball. It's okay.
What are the offers right now, Mr.
We'll talk about it later. All right.
Wow.
Yeah. Man. So here's what we need to know. When you see the notation F parentheses X parentheses, you need to know that that just stands for a function that is in terms of X. This tells you that on the other side of the equation, only X's will appear.
Oh, shucks.
Which is what we mean by this is just a one variable function. Okay? Now, usually you think about this as y. Okay? Which helps to think about it like that. Y and f of x represent the same thing. So if I asked you f of 2, what does that stand for? It stands for the output of the function when what? When x is 2. In other words, it is the y value when x is 2. Does that make sense?
No.
It doesn't make sense?
It's the Y.
You just think about it as the number you plug in for X.
Well, yes. This is the input. And the whole thing represents the output.
So whatever the equation is, that'll equal 2. Or no?
Say that again?
So like, let's say we have 3x minus 2, and whatever we put in will equal 2.
Yes. So we'll do an example, but you guys, sometimes you guys remember all these tricks. You see f of 4, and everybody knows, oh, yeah, you just plug in the 4. Well, that's great, but you need to know what's going on. 4 represents the input, and then your answer, the x's. And then the output is what you get. So, for example, oh, and by the way, I didn't say this, but I think you guys know this already. You read this as f of 2. This is read as f of x. That's how you read it. Okay? So I don't want to hear anybody saying f2 and fa and fu. Whoops.
I
That's
actually
not what I
put
meant.
15 that their initials were fundamental university.
Okay.
He's like, F you up.
So let's say f of x equals 3x squared minus 1, all divided by x plus 1. And now the question is to find f of negative 2. What does that mean? F of negative 2 can be found by plugging in negative 2 into all the x's. Slow down there. Hold on. You already guys said I'm a little slow. We all know that. So let's see. We get negative 2 squared is 4. 12 minus 1 over negative 1. So negative 11 is good.
Oh, I was right.
Of course you were right.
You just talked.
Okay. So what this means, again, this means that when x is negative 2, what's y? Y is negative 11. So on the graph, I don't know what f of x looks like necessarily, but I know that negative 2, negative 11 is part of that graph. Okay? Now, in addition to plugging in numbers, you should also be able to handle plugging in variables. So if I asked you to calculate what f of w equals, what does that mean to do? Plug in w for x. So now f of w is literally going to be the same thing, but now w's. And in this case, we don't really do much else with it. We just need to understand that if we switch the variable, that's what it looks like. But more importantly, this is what we're going to head up to in a couple of sections. You can plug in more than just one variable. You can plug in different functions. So let's try this last example. What if f is we want to find f of a plus 1. So yes, now we, instead of x, everywhere there's an x, we say a plus 1 squared minus 1 all over, instead of x, a plus 1 plus 1. And we can simplify it and say 3a plus 1 squared minus 1 over a plus 2. Okay, are there any questions on how this works? Numbers, variables, it's just literally swapping out the x and substituting in what the new input is going to be.
On the top, would you factor that out and actually do it?
What's that? Here, could you? Yeah, you could. And it depends on like what we're going to do with it later. Like if I say find the new x-intercepts or something, then maybe you're going to multiply it out. But if we're just looking for a rule, this is fine. Okay?